So actually, yeah. So today we're going to talk about Ajax, right? I just leave this here because I think it's delightfully hilarious and has absolutely nothing to do with lecture. Does anyone know what Ajax stands for? That's right, asynchronous JavaScript and XML. So who knows what XML is? Yeah? It's a powerful programming language like HTML and CSS. Not programming languages. So those are just markup languages. So what XML is, it looks just like HTML. Notice how you have this head tag that opens and you have a head tag that closes. So in XML, right, instead of this like doc type HTML, it would be something like, I can't actually remember, it was like XML and then it was like version and then like 1.0 and then it would stop and then you would close out the like XML tag. Actually, I think that's incorrect. But either way, the idea here is like you would have some sort of XML and they would look just like HTML. So if I wanted to send you a message, right, I would just be like, there's an email tag, and then I would close the email tag. And then in here, I would put like header, right, and then, this is so lame. This is so lame. Lame. And then if I wanted to, then I would put like subject, right? You can see already how like whackadactyl this is. Like, okay. And then inside the subject, I would put like subject text. Okay, subject text. Ugh. And then finally, I'd be like, this is the subject. So it looks just like HTML because it is another markup language. All this markup language does is hold data versus what like HTML is usually used for is to render something to the DOM to create a beautiful user interface that we know as websites today. Cool? And the reason this is like XML is that if I wanted to go get data from like a server somewhere, I'd have to format that data in a certain way so that I can grab it where that there are values associated with some sort of title. So if I wanted to grab the subject text, I would make a request that holds this XML, and then inside the email tag, inside the header tag, inside the subject tag, there would be a subject text tag that I can then grab that data from. And so that's kind of like the old way of doing it, and we're going to like get back to this at some point. The idea here behind Ajax is let's take a look at something that we all know and love, and that's Ruby, right? We love Ruby, right? Yes. Thank you, Ruby. We love you, Ruby. Nobody ever joins me. It's kind of sad. All right, we don't need this. Bloop. Let's get that. Cool. So the idea here is I'm just requiring a couple things, right? REST client, which I've talked a little bit about if like you haven't used it in Mod 1, and that is this is the gem that's going to help Ruby make these network requests. We have JSON, right? And what does that stand for again? JavaScript Object Notation. Cool. Right? Oh, yep, it's right there. Smart. And then we have pry, right? Our good friend because I make a lot of mistakes, so we want to make sure that we can drop that debugger. So all this is going to do is it's going to print to the screen, right? Like, hey, I'm just going to take this quick power nap, and Ruby has organically a sleep function. Yeah, both Aniket and I don't want to break it with our power. It might need a gentle touch. Oh my lord.
No, it's going to be useful.
I don't currently know what's on my Slack, but Charlie++. I don't want to like pull up my Slack for the recording, you know? Be me being like, oh my god, Matt's a dirtbag. Oh, hey Matt, wow. We were just talking about you and how much we love you, Matt. Yeah. I owe you guys for that one. All right. So look, check it out. Ready? It's just going to say I'm going to take this quick nap, right? And then it's going to sleep for 5 seconds. Sleep is an organic method inside Ruby. And all that does is it's sort of like a wait. And then it's going to put, okay, I'm awake now. It's going to stretch. And then it's going to say I'm going to make this HTTP request using REST client. So all I'm going to do is do this REST client.get. And notice that I'm doing this .get because what type of request should this be? Right? Get, put, patch, or post, maybe delete. And so I'm telling REST client to do a GET request to this particular URL. This is just a Heroku app that goes through a random array of Ron Swanson quotes. If you know who that is, enjoy. If you don't, they're just quotes. Cool? They're like Abraham Lincoln, but snarkier. Yeah? And so all I'm doing is saving this into a variable so I can reference it later. And then I drop a binding pry. And so let's take a look at what the behavior actually is of this app. So I noticed that I have a file called sync.rb. So I'm just going to run ruby sync.rb. So what we expect to happen is simply this. I'm going to take this quick nap and then like 5 seconds. And all of a sudden it's going to go, I'm awake now, and then it's going to make the request. So we can look at this sleep function as this sort of blocking function where nothing can really happen until that sleep is complete, right? Like notice line 10 didn't execute until the sleep function was done. Yeah.
How did you make a private working at the very end of the document?
Say again?
Like without putting something after it. I thought that private working there was nothing after it.
Actually, the comments technically count as commented code, and so that'll trigger it too. So the idea here is I want to look at what Ron Swanson quote response. I should have named that a shorter variable. Ironically. All right, cool. What do we think the type of object will get back? What kind of object should we potentially get back? What do you guys think? Right, a REST client-like object. In the same way that when we did bcrypt, right, and the namespace password.create, we got a bcrypt object back when you were doing that auth. So if I take a look at that Ron, sorry, yes, oh, bless up to bat, Z shell, great. Naturally, I get this like REST client type object back, and it's a response object within the REST client. And notice I can kind of see the data that's in there, but not exactly. So it's a REST client object. Does Ruby really know what to do with these REST client objects, or should we probably try to transform them into something that we do know? Transform them. Yes, we should transform them, right? So we talked a little bit about JSON and that it was this language agnostic sort of hash or object or dictionary, like a key value pair. So most things on the internet, most things, when it comes to data, will be in this like JSON-like structure. So if I'm making this request and it's giving me back JSON, I have to take that JSON and transform it into something that Ruby knows. So the way to do that is you simply have to do json.parse, and I have access to JSON. I should have access to this JSON because I've required it. Cool? It's not necessarily like organic to the language, although it kind of is. So if I take this parse and I put in the Ron Swanson quote response, let's take a look at what I get. Powerful. Creativity is for people with glasses who like to lie. Nice. So if I were to actually take a look at the class, right, because this is important, we should always be looking to identify the type of object that we're working with. And that, it looked like an array, but let's just verify. So what is it? Bloop. Oh, it's an array, which is great because now I know I can use .each, I can use .map, I can do .find on this because it's from the array class. Cool. So any questions on kind of like what's happening here? All right, good deal. Let's get out of here. All right, so let's take a look at how JavaScript will do it. So JavaScript, unfortunately, doesn't have an organic sleep function, so I've had to write one. This is very complicated math. It's not, it's just, so I just have the sleep function, right? It takes in a random number, or any number you want. I'm going to use let I, and it's going to start at 0. The idea is that this while command is going to run until it finishes. And so all I'm going to do is take I until it's basically 12 to the 8th power. We've kind of had to like play with this number because different computers run at different speeds, and this one's so powerful I had to make an obnoxiously large number. And then it's just going to count up until it hits this number. What I found is putting in about 10 would be about maybe like 6 or 7 seconds, something like that. So I'm going to do something very similar to what we did in Ruby, and that's I'm going to console log, hey, I'm going to start the sleep function. Cool. Then it's going to go to sleep, right? So it's going to do that while loop. And then it's just going to say, wow, that sleep function took forever to run. 1 star. And so if you take a look at the page, I have this right here. Okay, this ajax is just a click button. Let me clear this out. And all I'm doing is I'm asking the document to get element by ID, or I can query select, right, this click button. So if I take a look at my HTML, I have the click button right here. Cool. And all it's going to do is I'm going to add an event listener. So when I click that button, all I'm going to do is console log. Yo, whoop, there it is. Cool. So the idea here is if I were to actually hit refresh, I should see the log that says, hey, I'm going to start that sleep function. Then it's going to run the sleep. And then once that's done, it's going to console log, wow, that sleep took forever. So let's hit refresh. Bloop. Interesting. Oh, I didn't save it. Wow. So embarrassing. So embarrassing. Cool. Let's hit refresh one more time. So it's starting the sleep function, right? And then it takes a few seconds, and then finally it processes. Cool. So let's actually take a look. Why is that actually running? Oh my God. That's embarrassing. I didn't wrap this function. Whoop. Cool. Great. So the idea here is I want you to kind of like listen to what's happening. So when I hit refresh and it's running the sleep function, I'm going to jam at this like click, right? So notice that while I was clicking, while that sleep function was running, that button click, even though that event was firing, JavaScript could not process it and nothing could happen until the sleep function was done. So the idea here is this sleep function, that while loop, is considered blocking. All right, so we saw a little bit, we talked a little bit about it inside that video. Blocking code is not necessarily anything except code that takes a really long time to run because nothing else can run while that slow code is running. And so the idea here is when you're on a website, right, do you remember like surfing the web back in like the early 2000s where certain websites, you couldn't do anything until the whole thing loaded. You couldn't scroll, or if you clicked an image to make it bigger, like while that image was loading, you couldn't do anything else. And that's because everything was happening synchronously. Like until that was done, you couldn't do the next line. So the reason we use asynchronous code is purely because we want to create a better user experience. If I click something, I want something to happen in the background, but I still want to be able to interact with my website. I don't want any blocking code. I don't want any noticeable blocking code. Cool? So let's take that into consideration and see how do we actually make web requests in JavaScript. What is the very cool word we're looking for? Yeah? Sure.
When you mentioned like did it still log clicks or log pages?
Okay, the good question is, did it actually log my clicks? It logged all 12 of my clicks immediately after that sleep function finished. So even though I was clicking while the sleep function was running, none of those interactions actually happened until the blocking code completed.
Like the 12 is not like after you loaded them the 12 times. The 12 is included in before the whole thing.
Correct. So like if I hit refresh again, you'll see I'm gonna click, 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 and I'm gonna take my hands off, like a G, and then you'll see all three there happen. Yeah? So I didn't like wait until it was done, then I clicked it 3 times. Yeah? So it's basically queuing up those clicks until the sleep function is done. Once that's done, all 3 sort of fire, which would be a terrible user experience, right? Like what if you like did that with your credit card and you're like, I'm gonna buy this. You're like, huh, nothing happens. And you clicked it again. You're like, huh, that's weird. And you click it again, and all of a sudden you have 3 couches coming to your door. I was just shopping on Wayfair.
Why did register 5 then?
Oh, I think I clicked it more than 3 times. Yeah.
Double.
I mean, this touchpad is sensitive, you know? It's powerful technology. Great. Cool. So, all right, let's actually take a look at like how do we make web requests in JavaScript. So, what do we learn about in the labs? Great. So this command, right, this API called fetch, actually comes from the window object. Fetch is not organic to the JavaScript library. We talked a little bit about what this global object was like a while ago. But the global object is this window. If you take the window, you'll see alert actually comes from the window, because if I run alert and I go yeet, or actually JSON Derulo, right? It does this window.alert because it's the window, it's the browser that's doing the alert. JavaScript has no idea what alert is, but Chrome, the browser, does, right? Because Chrome is the one that gives you the alert, right? I'm not getting that alert from Atom. I'm not getting that alert from the terminal. And so if I take a look at some of the other functionality, I also see something like boop, boop, boop. Oops, I can't alphabet. Boom! Fetch, right? So fetch actually comes from the browser. The browser gives you this functionality. So the same thing as doing simply alert like this, I could do window.alert, which is a function that the window object gives me. The browser gives me this. So I can do fetch just like this, which is a function, or I can do window.fetch, because it's the browser that gives me the fetch sort of API. Cool? Any questions on like where fetch is coming from? Who feels like they understand where fetch is coming from? Okay.
Do all browsers understand fetch? Or just
Modern browsers will understand, right? So like, I'm not sure, I think IE even, but if you're on like Netscape Navigator or like NetZero browser, like BlackBerry browser, probably not. Cool? If you're ever wondering like, hey, can I use this certain API or can I use this certain CSS as things evolve in technology, there's a very cool website called, what would I want to name this website if can I use it? So powerful. Wow. So what is fetch? Fetch is available in all Android browsers, kind of. So Opera Mini does not support it, right? IE Mobile does not support it. BlackBerry, like I said. Oh wow, just kidding. Internet Explorer does not support fetch. But Edge, Safari, and then like you'll see this yellow one, meaning like some of the functionality of fetch works in this version. So sometimes when they're like, oh hey, it doesn't work, try updating your browser. Like this is kind of like the idea behind it. Cool? So powerful. Good question. All right. So I'm in this fetch, right? And fetch receives what as an argument? What do I need to put in fetch? Yeah, like what I'm actually going to go fetch, right? Which make a sense. Oops. Bloop. It's Command V, so that's why you saw V. Great. Now, fetch does what type of request? What do we tell REST client? What type of request did we do? A get, right? So the idea is that the first argument is like, where do you want to go? And the second argument is, what type of request do you want to make? So I can tell it for the method that this should be a get request. Now, what is like the default request sort of in the browser, or like really just most of your requests anyway? They're get requests. So in theory, if you're making a get request, the get part is sort of optional because it would just default to get. Cool? I'm going to leave this in here to be a little bit more explicit so that you can see it as you're sort of like getting used to the syntax. Right? Because I think you're introduced to this like yesterday. Right?
You have to close up that method.
Huh?
nothing close.
Oh yeah, embarrassing. Good looking out. Cool, and let's just take a look to see what does this return. So I can console log this whole thing. Actually, what I'll do instead is I'll just set it to my data, right? And then all I'm going to do is console log my data. Cool. So what should we expect to see here? What have you learned from reading all those read use? Great, let's take a look. Bloop. The sleep function. It's getting me good. Bloop. Actually, we don't need this either. Great. So what we see here is it comes back with this like promise object. Right? The promise object only has two states. It's either resolved, meaning the promise is good, or it's rejected, meaning your promise was bad. And it could be for a number of reasons. We won't really want to dive too much into promises, but I can if you guys want to. The idea here is that there is something called a promise status and a promise value. So this was resolved, right? Probably because the GET request was successful and that URL existed. And the second thing is this value. In order to get the value out of a promise, I have to chain a method on it. That method specifically is known as then. And that makes a lot of sense because like what is a promise in real life? A request? In real life, like if I promised you something.
Since you're gonna do something.
Yeah, it's not gonna happen right now, but I promise it's gonna happen later, right? Like, yo, listen, let me borrow $50 and promise you I'm gonna give it back to you. I'm like, okay. So the idea is that if I wanna get to this promised value, I have to chain on a specific method onto the promise object, and that's a method called then. So let me get rid of this. Bloop. I can just chain it on by doing this, then, which is a method. But then notice how like it kind of like splits my fetch up a little bit and then it becomes slightly unreadable. The idea here is that JavaScript, as powerful as it is also like space agnostic. It doesn't really care about spaces. If I did this, so it doesn't really matter, but I can hit enter like a return. And then I can indent my then. So this then will actually be invoked on this fetch. But it's just slightly easier to read. And so here, this then, in the same way that the add event listener receives the event, what do you think this then should receive? Right, the response, right? What comes back from the fetch? What is the response from the fetch? So I'm just going to put response here. Actually, I'm not going to do that. So then, right, what should you do in the then? Like if I asked you to do something like, hey, can you go and grab this piece of paper for me? You're going to go grab it, and then you're just going to look at me with this piece of paper. And then I have to tell you what to do with it, right? So this promise is going to go make this request. This fetch is going to go get some data from some website, some API, some server. And then when it comes back, I need it to do something. So if I needed to do something, I should probably give it a function.
That response, that's not a promise object. It is.
So if I have to give it a function and I'm putting this function as an argument to the then, what is that function actually? If this then needs to call that function later, right, so this receives a callback function. Are you like starting to feel like callbacks are like okay? Cool. So boop. And like I said, this function receives a response. Bloop, bloop, bloop. So without doing anything else, I'm simply going to console log the response. So what is the response that comes back? Cool. I'm going to get rid of this because that doesn't exist anymore. Bloop, gone. Do I have to do anything or will I see this response on the console? Why would I see it? Well, here's the thing, ready? Fetch is a function. So there's a difference between fetch and fetch being invoked, right? So on line 25, is fetch being invoked? Yeah. So I don't have to really do anything because when JavaScript is running, it's going to see 25 and it's going to invoke the fetch. And then, right, which you can also see, bloop is also being invoked. And so this console log will run without anything else. Cool. So if I refresh, I see this response object. I see a response object. Okay, I can take a look at it. Okay. And in the same way that with Ruby, I got a response object. What did I do with that response object to make it so that when I had JSON, I turned it into something Ruby knows? So if I have this response object, how can I then transform? What should I be doing to this to make sure that JavaScript knows and understands what it is? I should parse it, right? So JavaScript does it a little bit differently. Boop, boop, boop. And then I'll take the response, and instead of doing the JSON.parse, which is how Ruby likes to do it, this response can simply... You play music? No, it's all right. Yeah, you have to run a function, you have to run a method called JSON. Cool? And as we know, we don't want to make this silly mistake, and I see a function here. What does this function return? Nothing. It returns nothing right now because I didn't put in return. That would have been embarrassing, right? But let's take a look. We see the response object. What does this look like after it's been parsed? So let's take a console log, nope. And let's console log the parsed JSON. Yeah? Bloop. Oh my goodness. There's another promise. But this one's also resolved. However, this one has a value to it. So let's take a look at what's inside this value. It looks like the data that I actually want, right? And what did we talk about earlier? You guys want to read it? Is that why? I see you guys like reading. This is like when people get a little too chum with me, I like to call them by the wrong name. So let them know that I don't really, cool. All right. You guys got that back there, Jack? Jack, good? Yeah. Sometimes when people get a little chummy, it's like call them by the wrong name. So that didn't go over well. Sorry. All right, cool. Remember, the fetch returns a promise, and in order to get the value out of that promise, what did we do? We chained a .then method. So this time, I actually want this promise value. So what should I do? Right, I need to add a .then here, but that code looks kind of gross, right? So let's clean that up a little bit. Okay. And .then needs to know what to do. So what do we pass it? Callback function. Boop, boop. Great. And in this callback function, it should receive what? So remember, this then, right, this callback function returns what right now? Nothing. So I needed to return that promise value. That's what I wanted to return. So this then will receive the previous promise return value. In the same way that this fetch gave you what? It gave you a promise. And the promise value was a response. So this received the promise value's response. Yeah? So if I'm returning this, what should be in here? Right, the parsed JSON, Derulo. I'm going to leave it in the lecture. I was just laughing like a maniac with old Chuck Downfield back there. Cool. So let's take a look at what this is. Is this confusing anyone? Should I just change it back to JSON? All right, actually, you know what? Let's just do this. JSON Derulo, cool. Oh no, it's capital. Great, JSON Derulo, great. Let's take a look at what this is. Oh my goodness, it's finally the value that I want. I'm a simple man. Okay, great. I'm not gonna finish that sentence. Oh, all right, so great. So this is actually what I want. So do I need to do anything else to this? Or is this finally the data that I have and that I want? So, right, I can see that the array is finally there. Should I chain on another then?
You want an array?
Well, yeah, I mean, I feel like I've got my data now, right? So I don't need this extra then. I've seen a lot of wacky things. Like on a code challenge, I'll see like 4 thens, and I'm like, okay. Right? But the idea here is like, now I have my data. I don't really need to then anything else. But we can just prove that the next then will receive whatever the return is for the next one. So I'm console logging the array, but if I return, right, I don't know, what do you guys like? Charles Entertainment. Oh yeah, let's do that. Oh yeah, it's powerful. Great. So if I do a then here, all right, this takes that callback function. This is going to receive the return value of this promise object. So if I console log the return value, what should I expect to see? Right, let me get rid of this console log, and there it is. So I don't actually need to go this far, right, if I already have the data that I want. Now that I actually have the data that I want, all right, what can we do with this array of data? I can slap it on the DOM now if I wanted to, right? I could do something like grab an element on the DOM, like let's say, let's take a look. Your quotes here. Wow, what a great place to put some quotes, right? Let's find that on the HTML. Where should I put that? Just thinking through. Right, and this like ID of quotes, right? If the ID of quotes wasn't there and I just saw a div, should we panic? Okay, yes, maybe for like half a second, and then realize how powerful we are, and then just add our own thing, right? Cool. So in here, do I need to grab the quotes div right at this point? Does it already exist on the DOM? Great, so should I grab it here or should I grab it somewhere else? Okay, maybe I'll put it on the global, right? So document.query selector, powerful. I think it was like hashtag quotes. Okay. And this is going to be const quotes container. This is equal to quotes. And then from here I can do what? How do I slap that on the DOM? I could create an element, and then what do I need to do with that?
And then to the
Okay.
change the inner text.
So let's go with option 1, right? And that is, right, let's create an element. And then we need to, so 1A. What do we need to do after we've created the element?
Change the inner text.
Change the,
Equal to the value.
right, equal to the text I want, which unfortunately right now is in an array. So I can use something like JSON Derulo and ask for the first item. Oops, that was weird. Ask for the first item in the array. That would work, right? But what if that array was multiple things? All right, I can like for each it, and then for each I can create an item. Oops, I can create an item and then change the inner text. So that's a way. And then lastly, 1B, I can then, all right, let's use this hand emoji. Oh yeah, let's use the default one because I don't want to like get into a fight with anyone. On the DOM, right? Just slap it right on the DOM. And how do we do that? Well, where do we want to slap it on? Right, so slap it on the DOM, and I can just do the quotes container, and then I can append the child of the newly created element. So far, so good? Okay. The other way we could do it, all right, is simply add to the HTML of the quotes container. So I can take the quotes container, right? And what is the HTML right now of the quotes container? It's a string that simply has a p tag that says your quotes here with the empty closing p tag. If I wanted to add to it, right, I can simply do the inner HTML, and I want to add to it. If I did this, what would happen to the p tag that was already there? It would be gone because I'm overriding all the HTML that already exists in there, and I don't want to do that. I want to add to it. So I'm going to plus equals, and then what do I want to plus equals? Oh, equal plus? Psh, embarrassing. It's a good thing I have you all driver navigating, just like a 20-person pair programming. Cool, so what do I want to add? Maybe like that element I just created, right? A little this action. And what's in here? Friggin' money, right? The brand new JSON that I just got back, probably like the first thing. Cool, let's take a look. There it is, okay. Very good. Any questions on how we were to like make a fetch request and then slap it on the DOM?
How is it refreshing? Is it like cycling through them?
Think about it like this, ready? Every time I hit refresh, it's gonna send a brand new fetch request. What I haven't explained is what this API actually is.
Is it actually randomizing it?
Yeah, it's just like, yeah, it's just a bunch of these quotes, but it just pulls one every time. When I eat,
Gotcha.
it is food that is scared.
I was gonna say we set up something to like normally that would happen in our own randomizer.
Yeah, so if I refresh, this rectangle is referring to like a computer. So he doesn't really know. Cool, yeah, so like, cool. So I'm making a brand new request every refresh, right? So every time I refresh this page, I'm making a brand new fetch request. So naturally, you'll see the quote change. Yeah? Question?
So if you go back to the fluid, because you have the second callback function already like returning that data in array, you don't need to do a return JSON or return JSON.
Yes. Remember, I'm doing this fetch simply to get data. Once I have the data here, right, I don't actually need to like return anything. At this point, I have the data. Now I can slap it on the DOM. I don't need to return anything because if I return, that's simply going to give me access to it in the next then, which we've all discussed that that's kind of not really useful. Yeah?
So would you not use like the arrow function to automatically return? Doesn't it automatically return it? The arrow function is the
Okay, very quick aside. Ready? You see this function keyword? I can have a function, right, named Chuck, boop boop. All right, and this can return Liddell. Right, what? Jesus? Okay. Sure, anything you want. Right? So, I don't know. Someone said that to me like earlier. I don't know why, but downfield, cool. If I had an arrow function, right? Const mat is equal to an arrow function. Right? Remember, that's basically the only difference. I can also return here. If it is one line, I don't need the curly braces. No need the curly boys. Or return. This has an implicit return if the arrow function is a one-liner. Cool? We're going to talk more about arrow functions. If you're confused about them,
No, it was more just on that specific one. If you change that then function JSON rule to an arrow function, you're saying that you didn't have to put a return. What would it do? Would it cause an error?
no, it does nothing. Right? Like this function right now returns nothing. So you wouldn't. The difference between a function and an arrow function right now, again, for what you need to know right now and your understanding, there's no difference. Cool? Any questions on just like this little tidbit right here? The one-liner? We're gonna get into arrow functions. It's gonna be boss. All right, so now I wanna like explain something to you. So we have a console log, right? This is where the drawing will happen. This is way before the fetch, right? For sure, smiley face. And this right here is definitely, maybe, no, after the fetch. Cool? So after I slap something to the DOM, I choose to console log something for fun, right? Just to explain a concept to you. And that is inside the fetch. Right? Question mark. What order should I see these console logs? Should I see 1, 2, then 3. Who says yes? Who says no? What order should I see them in? 1, 3, 2, right? Way before the fetch, definitely after the fetch, and then inside the fetch. Who here feels like they're comfortable in their understanding of why this is happening? Right? Okay. All right, let's play. Great. Here we go. Ready. My God, it's so powerful. So powerful. Thank you. Okay. Okay. All right. Okay. This is not turning out to be the best user experience. Okay, great. So there's a couple things, right? I told you that we talk a little bit about some computer science stuff, but like not too many. The first thing I want to talk about is. Okay. All right. This is just not. That technology was great, but it's just not helping today. So you're gonna unfortunately get the touchpad. I'm sorry. It's cool. Great. Boop. So we have this little like bucket, right? This little U. Bucket Y. So the idea here is this is what is known as like a stack, a visual representation of a stack. And the reason it's called a stack is because things go on a stack like this, right? Like a pancake stack, yeah? So I have these 3 delicious buttermilk pancakes. They're just off the griddle. And I want to eat this one like a savage. Can I get to it without removing these 2? No, right? So the idea here is that if I have a stack, right, and I put something in the stack, and then it goes on, and then I put another thing on the stack, and then it goes on, and then I put another thing on the stack, and it goes on. Before I can get to this one right here needs to come off, right? So if this one was 1, and this one was 2, and this one was 3, if number 1 was the first one in the stack, what order does number 1 have to come out as? It has to come out last. So the idea of a stack is this concept called F, first in, last out. If number 1 goes in, number 1 has to be the last one out. Cool? So it's called philo. I think like other sciences use that term. But first in, last out. Any questions on that? God, I'm sorry. This touchpad. Philo, you feeling good? All right, great. So, great. Let's do. Okay, I'm just going to use that. Oh, nice. That's pretty good, right? The idea here is, what if, right, we can visualize the JavaScript call stack in a stack-like object. So let's do this. If I had function, right, fun1, boop, boop, and let's do this, right? Then we have 2, then we have 3, and then we have 4. Huh? Now, function 1 is fun, and it likes to call function 2. And function 2 is a jerk and likes to call function 3. And function 3 simply returns, you done got me. And function 4 is, it just returns a string that says, I've been waiting for a long, long time. Cool? I think I told you why I sing that song. All right, not going to get into it in the recording of the lecture, but we can talk afterwards. So the idea here is, remember, function 1 calls 2, 2 calls 3, and then 3 returns. So I have a visual representation of a function. That's pretty good, actually. Oh my God. Wow, lecture's so fun for me. Must be all the coffee. That one wasn't great. So we have 1, 2, and we have 3, and then we have 4. Cool? So Nothing's on the call stack right now. But if I were to do fun1 and I invoke it, this is exactly what winds up happening. Function 1 gets invoked. So that pops on the call stack. Ooh, you like that? Made a wrong turn, but it finally made it, right? And it's on the call stack, right? So the call stack is how your JavaScript executes your code and why it's considered synchronous. So function 1 does what? Right? It invokes function 2. It calls function 2. So function 2 is like, oh, say what, fam? Got you. Coming in hot. And then it goes right here, right? And this is function 2. And then function 2 does what? All right. You like that? All right, great. I said at some point that we'd be having fun, but I feel like it's just me. So the idea here is, what does function 3 do? It returns a string that says, you done got me, right? And so now, you done got me is returned, and return does what to the function? It finishes the function, essentially, right? No matter what I have after that return statement, JavaScript thinks that function is done. And if it's done, it's going to go bloop. It's going to pop off the call stack. And so that one's gone. Bloop. Oh, dang it. Let's just say there's like, like someone took a bite out of function 2, but it's still there. What happens to function 2? Is there anything else left to do inside function 2? No, so function 2 pops off the call stack. And then is there anything left to do inside function 1? No, so now function 1 pops off the call stack. And now the call stack is clear, so that if I were to invoke function 4, the idea here is that function 4 will not run until function 1, 2, and 3 are all done. Because function 1 calls 2, which calls 3, then 3 pops off, then 2 pops off, and then 1 pops off, and now I am free to run the next line of JavaScript code, which is function 4 on line 75. Cool? That's asynchronous code, and that's why potentially code can be considered blocking when I have a log, which logs pops off the call stack. Now I have the sleep function on the log, on the call stack. And sleep is just doing its thing, it's taking a long time, just like kind of hanging out. And then sleep finishes because it counts to infinity and then pops off the call stack. And now the third console log will come and execute. And that's why when you saw it in the browser, it was like, yo, I'm going to start the sleep function, and then it waited. And then finally, this log happened. So feeling pretty good about like the execution context of JavaScript? Great. So let's take this, all right, one step further. Now, we know that network requests can take like a random amount of time, right? Who here is like started a Rails server and then immediately went to their show page, right? Like I'm gonna go to localhost 3000, animals/1. And then you could see in your terminal starting get to animals/1. And you're looking at your browser and you're like, okay. Because requests take a weird, sometimes long amount of time. But then other times you're running it and it's like blazing fast, comes back instantaneously. So the problem is these network requests, we cannot predict how long it will take for them to come back. Sometimes they'll take a little bit, sometimes they'll be instant, and it's based on a lot of factors, mostly your internet connection. Cool? The idea here is, what if function 1 was a fetch and I wanted to grab data from a server? And that way I could slap it all on the DOM so that the user can see it immediately. Right? Sort of like the index page for my website. I have to go into a server, get all the images of Pokemon, and then I put all the images on the page. The problem with that is, until that fetch comes back, nothing else can run. And that would be a one-star user experience. So let's just say function 1 was a fetch, right? Oh yeah. Okay, almost there. Right? If function 1 was a fetch and it popped on the call stack, and let's just say this was a synchronous request, that means that this whole thing has to do its thing. It's got to load. It's going to run. Once that network request comes back and I have the data, then function 2, well, I get the data actually, and then This pops off the call stack. So now function 2 can run. That would be a bad user experience because every time you make this request, it's got to sit there and it's got to load. And it's got to wait until it's done. So naturally, fetch instead is asynchronous. And how is it asynchronous? Well, the idea is that fetch pops on the call stack, right? I run my fetch. Cool? What does fetch return? When I first did const my data, and I console logged it, what does fetch return? Returns a promise. So if fetch returns a promise, it jumps on the call stack for maybe 0.1 seconds. It reads the URL, and then it returns a promise and pops off the call stack so that it can go get the data while function 2, 3, 4, and the rest of your code runs, so it's not blocking. So that's what's really happening. So if anything returns a promise, that's why it's considered asynchronous, because it just goes, hey, I'm just going to return you a promise object because I promise you I'm going to be back later with data. So that I can return immediately, so I can pop off the call stack, so I can not block the execution of the rest of your JavaScript. So far, so good. So where does it go when it returns a promise and pop off the call stack? Yes, that's why it was so important that you watch that video, because once that fetch is here, right, the fetch is here, it pops off because it returned the promise, and now functions 2, 3, and 4 can run. So while 2, 3, and 4 go on the call stack and do their thing, that promise, that fetch request went into something else. And that is this like web API sort of holding area where Chrome will keep track of it, or whatever browser you want, right? Mozilla or what else is a popular one? Safari. Good one. I'm just kidding. Safari's great. So Safari will take care of it. Safari, the browser, will take care of it, right? And so this thing is just going to load. It's going to do the network request. But who knows how long that's going to take? So you've got function 5 going on. You got a console log. And you got function 6 happening. And then eventually, when this web API gets the data, it finishes and successfully retrieves the data. It gets the array of quotes. It's going to push it onto a different data structure. And that is known as a queue. Queue. This is like one of the most weird English words ever because it's 5 letters long and it just says queue. They could have just left this right here and got rid of it, but it's fine. It's a personal opinion. I mean, they already have 1-letter words, right? A and I. Just might as well put Q in there. All right, so anyways. Q, however, is a different type of data structure. So if this request comes in, and then it goes into the queue, it's going to go boop, 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 right here, request number 1. Cool. If I had another request finish, it's going to go bloop, 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 2. And so what's going to happen is this. Once all of your jobs... Wow, that's pretty good. Oh, wow. Plus, plus. Once all of your JavaScript finishes running, right, it's going to go boop, 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 all the way until line 75, and it goes, great. There is nothing else here. JavaScript is done executing all of your code. It's going to look, right, and the queue sounds English, which it kind of is. English. The queue is very polite, and it will not enter the call stack until there's nothing else on the call stack, right? It doesn't play cutscenes, doesn't line jump. It's got a lot of manners. And so at the end of line 77, the call stack is clear, then the web request will pop on the call stack and come back. That web request holds the callback function, right, which should be this. It executes this callback function at that time. Cool?
So it executes the JSON parse inside of the API stack, or?
No, after.
After.
Yeah. So it comes back here and then runs the response.json. It holds the entire callback function and executes right now after the call stack is clear. Cool? And then what does that then return? What does the dot then return? I took a look at it. A promise, right? So if that promise, right, pops off the call stack, and then it pops right back into the queue, and then comes back again because we told it to. And finally, this then callback will run and slap to the DOM. So if we fully understand what's actually happening here, we can see JavaScript's going to run. Actually, I should probably get rid of this. Boop. JavaScript's going to run all this code. It's going to run this console log, right? The console log goes on the call stack, it executes, and then it pops off the call stack. The fetch will go on the call stack, immediately return a promise, and go into this nebulous web API that Chrome's going to take care of, and it's going to store the callback in there. And so then it's going to keep going, right? Because remember, it returned the promise. It's off the call stack. The fetch is no longer blocking the call stack. It's going to hit this console log and run. And then it's probably going to do all this nonsense, and it's going to see 76. Now the call stack is clear. It comes back, it parses the JSON, right? Pops off the call stack. It's still clear. This next then pops on the call stack, slaps to the DOM, and finally console logs. So that way, that's why you see way before the fetch, this returned a promise, popped off the call stack, no longer blocking it for a faster user experience. It logged this fetch, went all the way to the end of the call stack, came back, parsed the JSON, then came back here, and then logged. That's why this logs third. Are there any questions as to asynchronous code, why it's non-blocking, and how that call stack is being affected? Sure.
All right, my question is, if you had two fetch requests for two separate APIs, which one would come back, whichever one finished first, or whichever one was called first, since it
Yeah.
did that?
The question is, if I have two separate fetch requests, which one comes back first? The answer is you'll never know. And here's what happens. Fetch 1 goes on, returns a promise, jumps into the web API to handle. The browser's going to handle it, right? Now fetch 2 jumps on the call stack, returns a promise, and then jumps into this web API. Whichever one finishes first here will enter the queue in that order. So now, this is an intro to fetch. This is intro to Ajax. The hard part becomes, as you get more advanced JavaScript, how do I juggle that? How do I make sure fetch 1 comes back first? Because what if fetch 2 is waiting on the response of fetch 1? It's like, I need to make sure fetch 1 comes back first before fetch 2. And we can do an optional breakout thing afterwards on something like that. But this, all I want you to understand, actually I could see how disgusting this looks, but all I want you is to understand this, right? The call stack and asynchronous code and how it creates a better user experience and why the order in which you write things is not necessarily the order that you visualize in the execution. Are you cool with that? Yes.
What's the data type that the web API is giving the queue?
This right here is known as, I think, a heap. You can look into that. That becomes a little bit more complicated to explain, but I'll just go into queue really fast. So remember, the call stack is what? Right, first in, last out, right? The queue, however, notice how number 1 went in first. Which order does number 1 come out as? So the queue, the difference is the queue is first in, first out, FIFO. So those are two different types of data structures. And now you'll start to understand a little bit more about computer science, because that's how this language was designed, right? I needed a stack and I needed a queue. And like, okay, great. How did they build the DOM? Well, it's a tree-like data structure. And so as you start to learn and understand more data structures, your ability and your mind can process more and more complex problems. And so there's some importance to computer science and understanding the nitty-gritty of that. But here we just want to teach you the tools so that you understand the language so that you can actually do things with them, build features, have a great portfolio, and then like enter the job market successfully. Yeah.
And Ruby also being
Ruby is a synchronous programming language. The way it handles it is not asynchronous. It is through paralleling and multi-threading. So Ruby can run two separate Ruby files at the exact same time, whereas JavaScript cannot. It's like top down, left to right. So Ruby is multi-threaded. It can just split the workload amongst different executions of Ruby, where JavaScript can't. So in order to get around that, it uses asynchronous callbacks. And that's why JavaScript has callbacks. You can get into like callback hell, but it's the nuance of the language because what it was designed to do. Is that fair? Yeah.
Can you explain a situation of like a practical situation where this would matter?
A practical situation where this would matter? Sure.
Yeah,
If Sure, like if I was at Airbnb, right? Let's take a look. Oop. Where would you like to go? Antarctica. Wow, that's okay. When you going? Wow, great. And you checking out? Next, you know what? Somewhere Halloween. You're like, it's time to come back. Great. And who are you bringing with you? Everyone. One of you and all your kids. All right. 5. Great. So if I hit search, what's happening here is this. Notice how like the rest of the website is loading, but it sent a fetch request to get Antarctica Google Maps like location. And then it sent another fetch request to get like, I guess, Airbnbs in Antarctica. I'm surprised there's that many. Oh, it's saying I have internet connection problems? Just kidding. So, okay, that's not English. That's fine. But the idea here is that it sent a fetch request to get from the Airbnb database all the different places in their database that you can sleep in, right? It also made a fetch request here. While that was happening, I can still scroll on the web page, and I can still type in here. And while that's happening, I can still hit this More Filters button. The functionality of the website was not blocked while those requests were happening. There are certain pages that you were going to, like back in the day, where like while the image was loading, you couldn't do anything on the page. Like you would try scrolling or you'd try clicking on something, and then all 8 things would happen all at once. And so that's what asynchronous code will prevent, because it makes those requests in the background so that your JavaScript can continue running. If I wanted to click a button, that button click will still fire off that event, and my event listener callback will still run. Is that okay? Cool. I thought you started clapping already. I was like, okay, I guess I was kind of at the end. Yeah. Are there any questions as to like asynchronous code, what's happening in the background? Why do we do it? Why is JavaScript using asynchronous code?
Back to your illustration.
Okay.
What
It's atrocious.
At what point is, I think it's that box, but I'm not sure. At what point is the parsing happening?
The parsing happens, right, when it comes back on the call stack, because it actually will run the JavaScript.
Right.
It holds the callback. Cool? A good example to think of what this web API is doing is, you ever been on a website and then you've seen 1 or 2 pop-ups happening? So your website still loads, but those advertisements, those pop-ups, also are loading other websites at the same time. So you can almost think of this web API as Chrome making those requests, getting the data, and then pushing it to the queue. So those pop-ups, it's like loading multiple websites at once, except they're not pop-ups, they're just loading multiple websites in the background, getting the data, and then pushing it to the queue so that you can use it later in your .then in the callback. Yeah? All right, cool. That's all I have for you this morning.